Hello, everybody. So tonight we're actually getting into the module 5 stuff, the MySQL stuff. We'll start off with the module up with that example the other day that hopefully it made sense how the pieces tie together instead of just looking at the pure syntax, even though that wasn't really a full example. We are under tight time constraints in the classroom. So tonight is a big I really like data. I'm one of those people that just finds that really interesting, working with data and how computers can process through so much so quickly. I was excited. I've been excited about tonight's lecture, and one thing about tonight's lecture, we're going to connect to a MySQL database, but there are a lot of databases out there. A lot of relational and non-relational databases. So when they built the Java programming language, they had no idea what database we were going to connect to. So they kind of only have two choices there: either include all of the connectors or not include any of them. So they went with, and obviously including all of them would make everything bigger, not just the ones that needed to connect databases. So they went with the not include any of them. And then keep those separate from the default installation of Java. They're an official part of the Java programming language. They're just not in that default installation of it. But there are a lot of things like that. Here pretty soon, we're going to look at GUI packages. This came up the other night. And the official one for Java isn't part of that default installation again because, well, over the years, the people that make programming languages have learned that if they make an official default GUI package, it's kind of a big one, they end up stuck with it. They either end up stuck with it or they have to abandon backward compatibility. That's why the Python programming language uses a GUI package that was created in the late 1980s and looks very out of date these days. The one that Java is stuck with was created in the late 90s, so it's at least 10 years newer than the one Python stuck with, but they learned their lesson about including that official default GUI package in the default installation, because then you're stuck with it for backward compatibility, or you have to abandon backward compatibility. So the GUI package we'll look at in the Java GUI package we'll look at with the Java objects, where the buttons are Java objects instead of the HTML ones, like we've seen so far in class, and kind of what the modern world is moving towards, is an external library like this. And anytime we need one of the external libraries, it follows the same suit, follows the same path to get those included in our package with an IDE. It looks like the people that asked about using VS Code aren't here tonight. So they really like using that, and kind of want to learn about the background configurations and all that. But that's really what that is. Microsoft went ahead and put something together, but that framework was not intended for beginning programmers. It was a framework to build the exact text editor / IDE that you wanted. Because as a programmer, you know how to do that stuff. So instead of having to start from scratch, if you wanted to make your own, they put together a big framework where every programmer's personal ideal preference for a text editor or IDE could easily be built in a couple hours. So it wasn't really intended for beginners. Microsoft went ahead and put together one that isn't too bad to start with, and then they tried a new way to advertise text editors, like all those tutorials that you see where they brag about using VS Code. Those are basically commercials. Those people that work at Microsoft and some of their downtime out of their projects, they just make tutorials and talk about how great VS Code is. It's a good form of marketing for sure. But the Electron framework is had a different purpose when it was originally built. and setting everything up. Might be a little bit different importing that, so I will go ahead and show what goes in the command prompt as well as what we do in an IDE. Any of our IDEs kind of follow the same pattern, like we've been looking at NetBeans, but in general, if you're in IntelliJ IDE, IDEA, they added an A at the end of their IDE. Makes a nice little pronounceable word. That's a very popular one. Eclipse, like NetBeans, is open source project, so that's the old way before the Electron framework for making your custom IDEs. Downloaded NetBeans or Eclipse and source code and just started personalizing it. So that's what the framework really is, an improvement on that. Big, huge libraries that are ready to work with. What other popular ones are there? There's quite a few to work with, but most of them follow the same pattern. The difference is just where the button is located. They all have the same functionality in general. And if they seem to not have the same functionality, it's probably because there's a plugin that's not turned on, or a different plugin has been activated in the particular installation. A quick question for everybody. How many people have had SQL before? Some here in the classroom. What about you all on the Zoom call? We all have database, DBMS 110, see a thumbs up. So that's half the people tonight have had that. We are going to need that because we're going to connect our Java program applications to a MySQL database. And other types of databases would follow suit. I've been started trying to show NoSQL databases more often. Looking around, I found one that was actually made in Java that I really like, called OrientDB. They took effort, even though it's a NoSQL database, it's a node-based database. Well, it has several types. It has node-based and document-based, which is everything is a JSON file. Those they have advantages and disadvantages doing it that way. The big disadvantage is it's a JSON file, so you need the whole file every time. And we miss like the advantage of relational databases, which I'll draw a quick picture on the board to summarize why we use those. And node-based databases have a similar advantage to the big speed advantage we get from relational databases. But in OrientDB, they put a lot of effort trying to make the commands that you use very similar to SQL. So it's a really easy transition. The easiest one to transition between the two. They try to keep the terminology a lot the same, so I've been recommending that. And it's a big, fast, powerful one. There is a large company that uses OrientDB to deliver 400,000 ads per second. So if it can handle that, that's probably one of the biggest database needs in the world, right? To deliver 400,000 ads every second is a pretty fast database. Is targeted ads too. So it has to dig through all the data and figure out what ad to show each one of those 400,000 people, and then get those ads out, and then be ready to do that again. So a big, powerful one. You can look into it. From what we teach in the DBMS 110 class, I tried a whole bunch of different ones, and I thought this was the easiest transition from what everybody sees in the DBMS 110 class, which I'm pretty sure everybody has to take that class at some point. But for us, since that class is still focused on moving forward, there's going to be more non-relational database stuff in there, but that can move slow. Yeah, it's already been decided that that's going to happen, but when that actually happens is that's a different story. The decision has been made to include more non-relation, to make it more of a 50-50 between relational and There's some stuff that can be a little difficult in it, some of the high level theory stuff. Yeah, like some of that high level theory for all the advanced normalization and stuff like that, that can be pushed to a higher class where only the data analytics people learn that high level theory, and most people just learn the basics of using relational databases and non-relational databases. But there are some big advantages. So let's talk about, we're going to look at relational databases this evening. So sort of a review for some of y'all. We're not going to get into all the normalization and stuff like that. We just need some SQL statements. That's why I asked you to do that class. Because if you've had SQL statements, it's a lot easier. But for our in-class example, all we're going to do is insert data and do some select queries, maybe a delete query. Once all the queries pass in the same. So once you see how a query goes in, then you just send all the whatever query you want that way. Oh, a quick note, I almost forgot. I meant to say this right off the bat. Apparently I messed up the links in the reading assignment for this week. There's 2 chapters that relate to relational databases and something else that in the print version, they weren't included in the print version. I have no idea why they left them out of the ebook version. It makes sense that to put 30 chapters and then there's another 12 chapters. They had pick and choose 12 chapters that are available from like a little code on the website. It saves paper, and the books it's already a pretty thick book, a big heavy one to carry around. I have no idea why they left those chapters out of the ebook though, because they're obviously written and in digital format. But I linked to the PDFs, and apparently when I linked to the PDFs, I uploaded the PDFs to the files folder on the wrong course. So I had access. It was one of my courses. So when I checked the links, it worked fine. But y'all don't have access to whatever course that was. Somebody turned in a ticket for it, and I got the email right before class. So I haven't had time to follow up and do stuff because I'm not sure which course I uploaded them to. The link, the information that I have about which course it is in the computer version of it. So it's like a 6-digit number, a 6 or 7-digit number. And I know all the courses I've taught based off the name of the course. I have no idea what the 6 or 7-digit number course is. So I have to dig through and find where those are. But the ones I uploaded were also, at least one of them was a scanned in PDF. So I might just go back to the author site and grab the actual, grab a new version. So the reading assignment should be available by tomorrow. I'll try to get to it after class this evening. But yeah, I have no idea where those PDFs ended up. I uploaded them to the wrong course, and I had access to it, but apparently you all weren't in that other course, so you don't have access to wherever the link goes. I didn't realize that when I checked it. Okay, so the reading assignments will be up soon for this. But relational databases, which is something just about all of y'all's final projects sounded like they were going to need. Yeah, it seemed with the web application front end, it seemed like everybody just immediately thought of something data heavy. Put a database there and then dynamically bring a bunch of data to the web page, the stuff you're going to do in the SDEV 153 class. So this will also be important for people's final project. So the relational part, before I forget, add him to the list. I'll throw that and dump that out of the way. It's all about relationships, and we gain speed from that because databases store data. There's that technicality. A database just means electronic storage of data. Let's store that. The files and folders we have on our local machine, that is technically a database. It's a hierarchical database, but even if you're in a room full of people that know that technicality, you would not call it a hierarchical database. Even if you're sitting in a room full of software developers that all know about that technicality, if you said hierarchical database, they kind of look at you funny. So anything that stores data is a database. Relational databases are one of the big ones because they can be very, very fast and sort of optimize the flow of data from storage. So that's really what we need to do. I'll draw some quick UML pictures. So from our long-term storage, we're going to have some input feeds into our CPU, which is connected to RAM. Anymore, I always like to overlap those pictures because they're different, right? I think most people have seen inside a computer, or at least a picture of the inside. And the RAM chip is separate from the CPU, but a CPU can't work without RAM, and RAM is useless without a CPU to do something with it. And so we have some registers there as well. Volatile storage, just like RAM, but RAM holds the current program and registers hold the current step of that program. So the whole program or one step at a time might help to think about it a lot. Since we write the text files, think about the lines of code. Here's the whole file. RAM holds the whole file and the register holds the current line being run. Obviously, it's different once it's compiled in binary code, but that's a good analogy to think about. And then some output. That's not a parallelogram. So when we run a program, most of what we looked at so far, we saw some basic file writing, text files. We need that text file. We can store lots of data there, but the problem is that text file is all one thing. We either have the whole text file or none of it. So however much data is stored in a document, that putting in a text file, a sequential text file, it refers to how we store and retrieve it. As programmers, we need to know how to retrieve it. So that's why we call them sequential text files, because we put things in a certain order, and we know the order we put them into the file, so we can get them back in the same order. In general, that's referred to as a document database because we created a file with all our data. The downside of that is we need the whole file every time. We can't pick and choose from that file. Whatever that file is, I'll try to draw the little file picture. If we put it in a document, when we go to retrieve that, we have to grab that whole document and put it into RAM. And if our data set gets big, an entire a big, huge document is going to eat up a lot of RAM that could be used elsewhere. Parallel processing or other multi-threading, other software that needs to run at the same time. Everything needs that same RAM chip. And we have quite a bit of it, but we also have a lot of data in the world that our program might need to access. So that one can get big. We need something a little more efficient. Relational databases are a nice, highly organized version. The two big ones, to avoid writing relational over and over again, I'm going to switch to SQL and NoSQL. So SQL is structured query language. That's how we control the database. It's a programming language, but it's not like the Java programming language. Y'all might have heard somewhere along the way the difference, or one set of categories is declarative languages and imperative languages. Java is an imperative language. We're explaining how to carry out an instruction. Like set aside enough bits in RAM for an integer, then set aside enough bits in RAM for 8 characters, and all that step-by-step stuff, then do this particular calculation, then output the result of it. And how to carry out the task at hand. Whereas a declarative language, the things that need done, sort of a finite list, like in the database, grab all the data, or grab just a few select pieces of data, insert a new piece of data. So we don't just tell the computer how to carry that stuff out. We just use a keyword to say which one of the pre-built instructions we want to use. Declarative and imperative. So SQL is a declarative language, a bunch of keywords to control our database. Structured query language. And as I'm talking here, I'll also refer to NoSQL, which is often made to match SQL because SQL is what database administrators are trained in. So, and there's no reason that when we write something else, we have to name our method something different. So it still looks a lot like SQL when you glance at the keywords we use and stuff, but it's a lot easier to say and write than relational and non-relational. Those are big fancy words. But what SQL, what relational databases are, is all of our data is related in different formats. So each data point is a field, or a quote marks around it, that same point mark. Move the A over. Is a field or a cell in a table. Am I still on the board here? 1, 2, 3. I'm going to write it over here. And fields are related let me rephrase that sentence. There's a better way to phrase that. Related fields are records. So we might have this field, and then we'll have some other fields. So maybe we have something like a name and an age, town somebody lives in. That's my generic data. That's what our example is going to be tonight. Favorite food, some sort of ID value. But all of the ones about a particular person, all of those individual data points are related, so that creates a record or a row in our table. Related records form a table. And tables are related through common fields. So I'm just going to write some arbitrary labels up here. A, B, C, D, and E, that's name, age, town. Just have some sort of label. I'll make the notes look a little bit better. Tables are related to common fields. And each row would represent one individual person. So if we know a lot of people, then we'd make a few more rows that all have that same data. So then each person we want to represent in our database gets its own row in the table or record. And the fields, we have the same fields about each one. And will usually have more than one table. Am I still on the video? Yeah. E, F, G, H. I'm put that in the middle. I'll put C twice because that's the one labeled there. Let me color code that. That's easier to see and leave my trim. So this row right here, that first field I labeled, would be the same data as over here. It's often done with ID values. Most people, when normalizing a table, just keep adding ID values so that we have just a number that shows up more than once, because we do have a redundancy here, right? We're storing that same data twice. So like this record and this record would be about the same person. So maybe this is, well, like I said, name, age, the town they live in, their favorite food, their birthday, and this is where they went to high school. So the high school they went to, which might be a different town, but the person would be the same. So, and like when first learning databases and getting into normalization to minimize those redundancies, a lot of people actually just make up a lot of extra ID fields and then duplicate those ID fields, which isn't the best way to do it, but it works. But we have that same data showing up in two places. So these tables are related to each other. And on the record, all the way across that all those fields are related to that field that's marked in green there. Maybe I can do this so it shows up better in the video. And well, that's where the relationships comes in. Everything's related. So we can use those relationships instead of the data itself. So maybe we know this one. I'll pick up something arbitrary. Oh, maybe that's somebody's shoe size. We have their name, age, town, their favorite food, and their shoe size. So we know this person's shoe size, and we want to know where they went to high school. Maybe it's going to relate to some targeted ad or something. And where they went to high school is way over here. In some sort of text file or the file writing like we saw, we would need all of our data brought in, and then we'd have to sort through it in our program. But with relational databases, all we need to know is that starting value. We know that value, and that field is related to this field over here. And this field is related to this table over here. Then we can get to that data point we actually want. And all we need is the relationships. We don't need our entire data set. So it could be 20 people or 20 million people. All we need to know to get through it is how is the data related to other data in there. So we don't need our entire data set. That's the big advantage of relational databases and some forms of non-relational databases, or SQL and NoSQL is a lot easier to say. At the time we would choose to use each one is generally structured and unstructured data. So structured data, the easy way to think about it is think about a form, like a form on a website. Everybody fills out that same form. So you have the same data about every single person, which means that you will be able to fill in the same columns for everybody that filled out that form. no, unstructured data would be like what you can randomly grab from social media. No, one person drives a Mustang, somebody else ate at Applebee's last weekend. Another person's 10-year high school reunion's coming up. Somebody else got a gold watch for their retirement. And if we tried to put that data into a table, we would have more empty cells than full cells. That's unstructured data. It would be awful in the table. We would have more empty cells than values that we knew. And when we have that, then relational databases kind of fall apart because all those empty cells mess things up. So think about a table. When we can fill up a table, like everybody, we know the same data about everybody. So think of like an application or a form where everybody gives us the same data about themselves. That's when you want to use a SQL database. And when it's just randomized data, the data we collected is whatever we were able to collect. Then we want to use a NoSQL because we have to use something that works better when in a scattered form. Let me pull up a picture here real quick. So again, I tried a bunch of NoSQL databases, and from what we go over in the DBMS 110 class here at Ivy Tech, I thought OrientDB would be the easiest one to switch to. I'm just going to look at a picture real quick. OrientDB. And if I pull up images, OrientDB actually has a couple. It has a document database, but also a node-based database. So we have different nodes about each one of our data points. So maybe whatever this one is, we know this is maybe the blue is a person. We know their name, what type of car they drive, their shoe size, and it's connected in various ways. Maybe they went to a certain high school, which connects them to maybe this person over here that went to the same high school, but we know different data about them. We know who showed up at their kid's birthday party because there's a bunch of pictures tagged on their Facebook profile. Right? We have different data sets, so we have each one of the we have unique connections between our data representation. So it looks kind of like that instead of a table. While I'm here, every time that's OrientDB. It runs on port 2480. So you all probably seen that pop up, and when we randomly pull up Google and class examples, you've probably seen that pop up before. So that's OrientDB. It was actually written in Java, so it connects to Java very, very well. But the main thing I like about it, there's lots and lots of options, and I tried lots and lots of different ones. But what's covered in the DBMS 110 class, as far as using the database and typing in SQL, translates best to that. Normalization does not translate best. And I know you had the class for that class. You might have spent a whole lot of time normalizing your tables, which really we can get by without. I've made databases where every column is just a blob. You probably didn't even cover that in the DBMS 110 class. That's a binary large object. So basically that's just binary code. Whatever we have, anything that goes in a computer will fit. It is a binary large object. Until we need to get to a large blob or a very large blob. And at this point, our cell in the table can hold is close to a terabyte. So basically anything we want to put there. There's virtually no way to normalize database with that's made of all those, but I have done that before, and it all worked great. All kinds of duplicated data. I've done databases that were all a big, huge single table. Right? It's a place to store our data, And we get that efficiency of we don't need all of our data to find any particular thing. All we need is a starting point, and then we need to know the relationships between stuff. And that leads to something very, very, very quick. That's the advantage of it. They're very quick. They have very large data sets. I think that's everything I wanted to say about databases. Just about everybody has to take one, has to take the DBMS 1 class. So if you haven't had it yet, you will have to at some point. Or you had to transfer credits in from somewhere else, like transfer credits in from Prosser or another school, or some certification that you have that shows you you already have the knowledge covered in that class, which makes it cheaper, but it's still not free credits. I think it's like when you do that, it's like half price, half the cost of the course to bring in prior learning experience. PLE is what it is. But that's a distraction. So now let's do some stuff. Before we get to NetBeans, that is the other reason I asked you to install that virtual server, Champ virtual server, or some sort of virtual server. The X stands for cross-platform, and Apache, MySQL, PHP, and Perl is what the second P originally stood for, but we can set Python as a CGI script. That's a common gateway interface. That means basically anything on the NIC card. We'll define what goes across the NIC card ourselves. Most people do the Python for the second P anymore because Perl's kind of outdated, but whatever you want to call it, refer to those letters as. The M is MySQL, so that's one we'll need. So you want to start the Apache and the MySQL. And take note of which port MySQL is running on. MySQL is big enough that it gets a reserved port, so the default should be 3306. The port is kind of how we connect to a server, like HTML and or sorry, not HTML. That's just how we encode it. HTTP connects on port 80, and HTTPS connects on port 443. So both the client and the server agree that if any data comes across port 443, that's HTTPS data. Or if any data comes across port 80, that's HTTP data. So both machines involved in the communication are in agreement on which port they connect to, and both of them know which one to send and receive data on. MySQL is big enough that it gets its own one, port 3306. And the one we're going to use here is MariaDB. So when the guy made MySQL, he actually made two of them. Made that paid for expensive one, which looks really, really nice in tax write-off. Tax write-off come the annual tax season. Remember, that's important for software developers. When you start making that, you start making really good money. Those itemized deductions for the tax season are really nice. So he made that big one that excels, but he also made one that is open source and free to use. And he named her after his daughters, Maya and Maria. So Maya is the one that gets sold, and Maria is the one that's free. And in the years since after that, he spent a lot more time upgrading and making improvements to Maria, and they're free to use, much more user friendly in general. so the free one kind of is by far the more popular version these days. So once they're started, we'll go to a browser, and then you need your local host. If you like numbers, it's 127.0.0.1, unless you changed it, or you can just use the word localhost. And that goes to the default Jamf page unless you changed it, and there's a link for PHP My Admin. I'm just going to type that in there. The actual address for that is localhost/PHP My Admin. And this is just a web interface for dealing with a MySQL database. Interfaces for the graphical user interfaces for MySQL databases. There's a lot that can be done, which means there's a lot of buttons they needed to put on the GUI. These are definitely a little overwhelming. So on the tabs, you can see which server it's running on, and on the database tab, there's a create database button. This can be done as a query. I was just thinking for our thing tonight, might be easier just to go ahead and create the database, have the database existing, and then we connect to it. That's the more realistic situation that we'll have in the real world. As programmers, the server admins, server administration for whatever company would set up a database, and they tell us what that database is, so our software just needs to connect to it. But to create a database is just a query. I'll do it over here. So there's a create button right there. Just type in a name and hit create. But if you need to do it from your code, the create a database is, the query is create database, and then give it a name. I'll name it after our class, SDEV 200. That sounds like a good name. So really, this, when we get over to the Java portion and we're running and we're passing in SQL queries, if you want to create a database from your software, it's just that query. It's not a hard one. I guess if you wanted to, you could add if not exist. That's useful. That way you don't accidentally recreate it multiple times. And then there's a go button down at the bottom left, or the standard for the near standard for GUIs of direct database control is Control Enter to run the queries. And this is a text editor. You can write a whole bunch of code here. Control Enter will go ahead and run that query. And this will be important for us. What's that? What's the second word in that message it sent back? The first word, we know that one's obvious, right? We know where it's coming from, but that second word should hopefully strike you as something that's going to be important when we start writing code involving queries. So it returned an empty result, i.e. 0 rows. So our return from that query was 0. That will be very important, obviously, because we're going to need to know what, when our program runs a query, what do we get back? How do we know when it's done? How do we know if it worked? How do we know if it failed? All of that stuff. So create database successfully return 0 rows, or really successfully returned 0. And now over on the left-hand side in the tree, there's this SDEV 200. If you like GUIs, all of the buttons are here. They get a little overwhelming. Create new tables. Should we go ahead and create a table? Yeah, let's go ahead and create the table here, and then our software will just access that table. That's probably a realistic situation, right? The database admin of the company sets up the database, and they tell us what the database is and what tables our software needs to send stuff to. So really, the table would already be created and things like that. We can do it with SQL because this can be passed into our. We can pass this in the same way with this when we pass in an insert and select query for our actual example here before long. If you haven't seen it before, we want to create a table. So notice there's these keywords. That it's a declarative language. So essentially, it's a different syntax than we're used to, but create would be a method, and then table is it is different than a parameter. I don't really. We could think of it that way. Yeah, I was going to say parameter to relate to what we're doing. It's actually an extension method. It builds up in the background, but if we think of it like a method, create is the method, and then table is the thing we're creating. And table is like an object. So now we need the stuff for the constructor that goes in there. Which, since I just tied that back to object-oriented programming, I'll make a quick note on the board. I'll do it in blue. So up here on the board, I listed the official term for a cell in a database, a field. Or in particular, that's the abbreviated version. Really, it's a data field. And when we were talking about object-oriented programming, what did we call our variable? What we previously called variables, where we stored that. The spot that holds data, we call that a data field. And that is not by coincidence. Data field is, well, it's an object itself, but think of that as the primitive type. That's our most basic part of the database. That's our primitive type. We add primitive types together to build up something bigger. So a record is like an object composed of a bunch of data fields. Hopefully you're seeing a one-to-one correspondence there. And then when we make a huge collection of those, it's a larger type of object. We're building up more and more complex data types. But basically, it is not a coincidence that we use the same term for a cell in a table as we do for a spot to store data in our objects. A lot of people like to think of them like similar to variables, because that's the word we used before. Technically, they're not variables if they're in an object. A variable is for functional programming, and variables are references, so a variable would hold an object. The name of the object when we actually instantiate the class is a variable. So what's inside the object, the ints and strings and booleans and all of that make up our object are data fields. But it is the exact opposite of a coincidence. It is an important concept. So I want to make sure I point that out. So really, we are still, this is object-oriented programming, but it's predetermined. It's a SQL is a declarative language. Everything we need has already been made. So we're only going to ask for some pre-built methods. The method is, their function is create. The parameter is table, and table is an object. So we need the constructor for the object and a reference name for it. My generic go-to in class is people, name, age, town. That's an easy thing to make up a bunch of values for. And we need an ID typically we tie stuff together with IDs. We need a unique identifier in each row. It makes a big difference. Some sort of unique identifier, and starting out, it can be really hard to find a unique identifier. In a classroom especially. When you get out in the real world, you have so much data there, there's lots of data points about every person you have data on that you can find something unique. But in the classroom, we have much smaller data sets to work with. So it's usually an ID there. So I'll set up an ID, and that makes it great. Then we have something unique that uniquely connects to our other tables. Call it person ID, and some outline and some keywords. Primary key. Actually, I'm going to put that in a different order. Integer, primary key, auto increment. And I'm going to pause here and look at the predictive text. So there are lots of flavors of SQL. SQL is a category of languages. It's not a single language. So there are lots and lots and lots of flavors of SQL, of structured query languages. It's an entire category. And most of them are very, very similar. There are a few places we can look to try if we're not sure which one we're looking at. One of those is the word auto increment. Auto increment is often written differently. For MariaDB, it's an underscore, two separate words. Sometimes it's put together as a single word. Sometimes it's two separate words altogether. We have auto and increment. So that's just a little tip I wanted to point out. If you're not sure what version of SQL you're looking at, that auto increment is a good first place to look. Look through the SQL code and see if you can find auto increment, and that'll tremendously narrow down figuring out which language you're looking at. If it ever shows up. For us, it's the one with the underscore is what's used in MariaDB. Which also, MariaDB is what WordPress and Wix use, which are immensely popular website development, content management services. The end result of what the HTML, of what you started with that SDEV 153 course. The end result of that is a content management service. But WordPress and Wix are immensely popular ones of those, and both of those use MariaDB. And both of them recommend using PHP MyAdmin. So these are the most popular things you're liable to see out there. So our ID is just an integer, and we're going to let the computer keep track of whatever it is. It's just going to add them. So we never want to think about that ID. We just need to make sure there's something you can uniquely identify every single one of our records. And IDs are the good fallback. Usually if people don't see something within 2 or 3 seconds, they just throw an ID in there. And then my standard go-to is name, age, and town. I'm just going to do text. Those are at the DBMS 110 class. They probably went on and on and on about our chart. Variable number of characters where it decides, it varies how big it's going to be. It looks at, they all have to be the same space. So like if you say bar chart 32, it can be up to 32 characters. So the database is going to look through there, and maybe the longest name written there is 17 characters long. So we don't need all 32. It's going to cut that back, and then the entire name column gets 17 characters. If somebody comes along with a 21 character name, that's going to change. So it's variable. Much more efficient. Text is just 256 characters. less efficient, but easier to work with. We don't have to stop and think about how big our data is, because if you get it wrong, it just won't fit. Like you say, varchar 32 and accidentally pass in something that somebody shows up with a 33 characters in their name, the database just won't insert it. It won't throw an error, it just won't, but then it'll just discard the data. It'll be like, nope, doesn't fit, throw it away, and then just keep doing other stuff. So you'll end up with an empty cell. You won't even have an error message to know that empty cell happened. Age would again be an integer. And town, again, I'm going to do text, but if you want to be nice and efficient and all of that, varchar is probably better. Or like I pointed out, blobs work, a binary large object. Anything that runs through a CPU has to be a binary large object. There's nothing else that a machine can work with, so that works for all our databases fields. So we don't have to put any thought into it, whatever, just whatsoever. Just set up a bunch of blobs and then throw your data there or bring it back later. Then it's kind of like treating a relational database like a sequential text file. Horribly inefficient though. Yeah, I'll use that data because all we're really looking at is the syntax this evening. We'll see a small example, like I'm thinking this would probably be a good payroll calculator example at the end of this module or in the next module, or the next time we do an example to tie a bunch of things together instead of just looking at syntax, we will have a more a small but better and more meaningful database at that point. This gives us some data to see how to see the syntax for passing in a query. And again, on pretty much every GUI that controls databases, Control Enter is the quick way to run it. And once again, notice the return. It returned a 0. I'm going to run a quick insert query. Oh, wait, what? Why do I have unsaved changes? Okay. The table created, I don't know why I did it. I'm going to run one of the queries that we're going to do in our thing. Oh, there's a select query for those who haven't seen databases. Select, and the wildcard selector is just a fill in the blank. So that basically means select everything from this table where 1, as in 0, 1, false, true. So where all condition, every condition is true. So select, then from the table we want to go from, and then where is a condition. So like age greater than 30, age less than 12, name, name equals S asterisk. So then any name that starts with an S. And that's our starting point in those relationships, the where. So I think I said shoe size earlier. So where shoe size is 13, we find somebody with size 13 shoe and follow that around to whatever I said earlier. I think like somebody's high school reunion or something. And follow those relationships, and all we need is those 2 pieces of data at the end. We could have we could know that data about 1 billion people, but all we need is that first piece and that last piece and the relationships. Putting data in here, I'm going to erase this. You might want to type along because this, I'm going to delete this one from the row afterwards. I just want to show what an insert query looks like, because those of you all had the DBMS 110 class probably still have nightmares about inserting with SQL. It can be a mess because our keywords all make sense. We're going to insert into, so we're going to put, insert into, we're going to stick some data in a table. And well, right now we only have the one table, so people. And then in parentheses, we need to know which field we're putting data into. Oh, never did any SQL in the DBMS swimming class. That's not good. Yeah, that seems to be what that course is about. That's what that course should be about. That's why everybody has to take it, no SQL. So here's how we put data into it. Did anybody else not see any? I mentioned that course. Okay, that's useful. As long as you saw it before. I keep mentioning that course. If they're not teaching SQL, I need to start referring to a different course. Though the decision has been made to switch it around, and they're going to move that. The theoretical high level stuff is the only people that need to know that are database administration people. The people that are actually going to be administration for database. So there's no need to waste lots and lots of time with that elsewhere. So we want to insert data into one of our tables. Oh yeah, yeah, that happens sometimes. I guess you've already had the class, but before long it'll be cleaned up. So sometimes classes are a mess, but it should be cleaned up soon so that future students won't have to deal with that. Because you weren't the only one that had to deal with that. And there's a lot of people across the state of Indiana that take that same version of that course. Or another one that's kind of being adjusted, that Informatics 109 that everybody has to take, that has 70 over 70 writing assignments in an 8-week course. That's a lot of writing. Oh, distraction. Back to SQL. So if we need to put data in, we're going to insert data into our table, and the ID, we put that to auto increment. The computer is handling the ID, so we don't want to touch that. So we're going to adjust the name, age, and town fields, and then a space, and then what values do we want to put in those fields? And we do have to pay close attention to type. So if you have like a date time, if you have a date field and try to enter data in date time format, it's not going to go. So it's very, very strictly typed. And a lot of times you don't even get error messages. It just won't put the data in your table. And you have to figure out why it didn't work. So name, I'll stick my name in there. Name is a string. So just like in our, just like in the programming we're used to here in the Java class, strings get quote marks. Single and double are interchangeable to an extent, partially interchangeable. Basically, it's one or the other. Because on the town is also a string, so if I tried to use single quote marks there, that would be a problem. Or they need to be the same. Since I already used double quote marks here, I need to use double quote marks on the other. I can choose either one. It's interchangeable like that, but in the same query, I can't use both. That gets to be problematic. Some databases can handle it fine. Others, it will cause big problems. So choose the type of quote marks and stick with those for your queries. Which means when we get to Java, we'll probably we want to make sure and use escape sequences. Let's see, 44 is an integer, so no quotes there. And then the town is Clarksville. And then SQL does get semicolons at the end. There's an editor here, we can write lots of lines. So that's what an insert query looks like. Tag along, you might want to copy and paste that over to a text editor on the side or something where you can grab it later, because we have to build this up in our code, which can be a bit of a mess. So it helps to have a reference nearby. That's what I'm going to do. Well, I'm going to put it on the clipboard and then I'm going to run it. Okay, that query is good. So I'm going to come over to my text editor here and paste that in so that I'll have a reference whenever we go to build one and when we get to Java code after a break. And now if I come over here, there's lots of ways to get to it. We have the breadcrumbs up top, the tree down the side, different browse, structured accesses our table. You can see the structure of it, lots of different things. If I come over to people, there's that data in there. I'm going to delete this. Well, I can leave it in there. Notice we have delete and copy edit buttons. I guess now I'll run well, there's one there. I'm gonna basically we'll do a thing in our code for our syntax example. We'll do some insert queries and then some select queries. So select name from SQL is not case sensitive on the keywords. The variables you made up are, so if you spelled name with a capital N, you need to keep typing it that way. But on the keywords, it is not case sensitive, but it is convention to write the keywords in all caps, and then your own stuff in camel case, Pascal case, or lowercase. Because if you're staring at lots of SQL code all day long, it helps to single things out. It's just convention. It's something you'll commonly see. So select name from people, the people table. And so we're selecting one of our fields from a particular table. And then we can do some sort of condition, like where name equals, and name's a string. So I know what the name is. So I'm going to do C wildcard to character. There's only one name in there, so I'm going to match it. So select the name field from the people table where the name starts with a letter C. And any of our conditions, when we get to age, I guess age might go there as well, where age is greater than 40. That would also hold true there. Or if we're just doing a select query, we can leave off that end part. A lot of people don't like to admit that, just for consistency. Being consistent goes a long way. And you usually have a condition, so the standard way to do that is where 1, and in this case it's not integer 1, it's true 1, as in 1 0 and true false. So 1 is true and 0 is false. So obviously if we said where is 0, we wouldn't get any results back, because yeah, that would just be false. But we can leave that off. There's only one thing in here, so when I run that, you can see the result is only the name field instead of our entire data set. And look at the result. So that's the return, showing rows 0 0 1 total. Oh, I forgot to pause and say that on the insert query. I'll do another insert query so we can look at that, because that was the thing I wanted to look at. We need that. So 1 row was returned. We got 1 answer back. The return on a select query is how many rows there are. So if there are 50 rows, the return is 50. If it just doesn't meet the condition, like we said, where the name starts with C and none of the names there started with C, we would get a 0. What we want to watch out for is -1. -1 means error. So same thing on an insert query. I'll go over here and run another one. Actually, it's still on the clipboard, isn't it? Yeah, still on the clipboard. So when I run that, notice our return again is 1. So -1 is an error. 0 or positive numbers means it ran successful. And 0 is a success because we might have just not done it. Especially on select queries, we have those conditions, so maybe we just didn't find anything that met the conditions. So 0 is a valid return, but so our condition to check would just be greater than, not less than 0, not negative. Lots of different ways to do it. Greater than or equal to 0 does not equal -1, but most there are some situations, certain databases where it won't just always be -1, it'll be negative something for different codes. The different negative numbers mean different codes. So usually we do greater or less than. 0 and positive numbers are the returns we want. Negatives indicate a error. Wasn't sure. Oh, something useful. If you spend a lot of time drawing ERD diagrams in your DBMS 110 class, over here on the right-hand side, I need to move the Zoom thumbnails are in the way. Oh, I can share log in here. You can see it on your screen. Over here under, if you go to make sure the breadcrumbs are at the database level. If you go to more, there's a button that says designer. So here's where you would it generates the ERD diagrams. There's only one table. It would show all the arrows and stuff. Kind of like the UML class diagrams, we've already drawn them a couple times. It doesn't take any thought to draw those diagrams. So a computer can draw them, but a human has to organize them. Let me just make a quick query here. Create table. I don't know, fave food. We won't use this. I'm actually going to delete it. FID integer. Yeah, I'm going to delete this in 2 seconds. So food is text. I just want to do this for the whoops. Those buttons. I just want to do this for the diagrams. Design it. So we have 2 diagrams, but notice how far it separated them. A computer just can't organize them. It often does stuff like that. It'll put them in random spots. Sometimes they'll be generated like this. Sometimes like this. There's hardly an order to it at all. So we can create relationships between them. But if you set up the relationships, it shows on the diagram. UML class diagrams are kind of the same thing. We draw them a lot in class, and like I showed the other day, I showed that messy one. They're actually the nice clean ones that are polished off and drawn with fancy software and aren't the useful version of them. The useful version of them is the mess scribbled out on a dirty napkin, right? The collection of our thoughts. That's why they're useful. And if we need them for the end, then we can just generate it because it doesn't take any thought to generate them. It only takes thought to organize them, make them readable. Actually, the generator I'm going to look at for the UML class diagrams puts them all on top of each other so that we have to organize them. No matter how many class diagrams there are, they're just stacked up in the top left corner because a human's only needed to put them in a nice clean order. Okay, so that gives us a table to work with. There's a database connected. The server admin for our companies sends us emails like, okay, the database is ready. Whenever software, here's the connection details. So now we're ready for our Java program to connect to this. We'll do that after a break though. Does 10 minutes sound good to everybody? I see big head nods in here. 7:19, so we'll get back to it at 7:29.